All right, so this problem is a little bit misleading. This is problem 6 because it asks us to find what the value of F is. So you might think that it's a good idea to treat the first and the second block as one system and think about this one external force that is acting on the 4 kilograms of mass. The problem with that is that you don't know what the acceleration of the system is, so that's not going to help you too much. Instead, you're going to want to think about each of these individually. So let's call this block A and that block B and make it a bit easier on ourselves. And then let's start thinking about our system. So system A is going to have less interactions than system B. There's going to be the interaction between it and the mass of the Earth, so that's going to be its weight force. So you can go ahead and say 1 kilogram times 10 meters per second squared, or mg, which is 10 newtons, if that helps you. And then the normal force is, we'll call that normal force A since we're going to work with system B later. And they're going to be equal. Those lines should be the same size. And then the only right force, or the only interaction other than from this surface, so the normal, that you're seeing is tension here. So this is going to be tension in the wire. And if you want, you can just go ahead and call that 2 newtons because this is an interaction between A and B. So the 2 newtons is felt by A and the 2 newtons is felt by B. It's just that the direction of the force experienced is different. So the 2 newtons goes here, and this doesn't quite let you think about too much. This tells you that the sum of the x forces on system A, it's just 2 newtons. That's all that it is. And if you want, you can say that this is equal to the mass of system A, which is 1 kilogram, times the acceleration of system A. Now, we've dealt with this before, but I can assume in this problem, as long as this rope isn't shortening or expanding in any way as these two objects move, that the acceleration of A and the acceleration of B are actually the same. So we can just call that the acceleration. So rather than call this acceleration sub A, I'm just going to go ahead and call it A. And then that will be useful for me because I can say what A is equal to. Now, A is going to be equal to 2 newtons divided by 1 kilogram. And 2 newtons divided by 1 kilogram is just 2 meters per second squared. Okay, so since I know what the acceleration of block A is, I know what the acceleration of the system is. So now I could solve this as one system, system B. But instead what I'm going to do is I'm actually going to think about the system of A and B together, so both of them. So the system A and B together is essentially going to have the weight force acting down, which in this case would be 4 kilograms times 10 meters per second squared. So you would just say that that's 4 newtons. We're not going to use it. And then this also has its own normal force that's going to be equal. Now, in the entire system, so I'll just draw a dotted line around this system. The entire system, the only force acting on this in the x direction is this external force. That's the only interaction because we assume friction is negligible. So the surface is not resisting it in any way. So when I draw this force over here, this helps me realize, oh, if I sum the forces in the x direction of the system, there's only that forward force. Now this isn't equal to 0, obviously it's not balanced, so the system would accelerate, and I know that that would be the mass of the system, A and B, times the acceleration. Well, the mass of the system A and B is 1 plus 3 kilograms, so that's going to be 4 kilograms. And I know what the acceleration of the system is because I found it here. So the acceleration of the system is 2 meters per second squared, which means that the external force is 8 newtons, because a kilogram times a meter per second squared is a newton, and that is option